Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the part 2 video of the semiconductor devices, right? So here I have already discussed about the electronics, electrons and holes in a semiconductor. So let us revise it. So at a room temperature and some of the valence electrons acquire thermal energy greater than the Eg and move on the conduction band. Let us consider there is a conduction band and a valence band, right? So this is your conduction band and this is your balance band, and there is an electron in a valence band. What will happen if it will gain some of the energy? So it will enter into the conduction band. So as soon as it will leave the valence band, so this hole will be created, right? And here electron will be there, right? So this vacancy is called hole, and if it is a seat of the positive charge, so this hole can be considered as a positive charge, okay? And the free electron will move in a conduction band, right? So I hope you have understood what is electrons and what is holes in the semiconductor. So from this we can again from this diagram you can understand that at a room temperature what will happen, some of the electrons will try to empty this space and come out from this to this place. So it means there will be positive charge will be created, okay? So whenever bond, see, broken covalent bond, whenever bond will break down, so what will happen, electron will come out, and what will happen, there will be a hole will be created, right? Now there are basic two types of semiconductor: intrinsic semiconductors and extrinsic semiconductor. So I will discuss this both one by one. So first of all, you need to understand what is intrinsic semiconductor. This type of semiconductor is called undoped. Undoped means there is no external things or external material is mixed, right? So this is called undoped semiconductor or I type of semiconductor. It is a pure semiconductor without any significant presence of dopant species. So like pure germanium, pure silicon in the natural state are called intrinsic semiconductor, in which there is no external material has been mixed in this semiconductor. So the number of a charge carrier is determined by the properties of the material itself, that is the amount of impurities. In intrinsic semiconductor, the number of excited electron is equal to the number of hole. So this is very important property in intrinsic semiconductor. Number of hole is equal to number of electron, right? Ne. Ne is equal to NH at a temperature 0. The balance band is called field. The energy gap is 0.72 electron volt. So Eg for this case is equal to 0.72 electron volt, and the conduction band is totally empty, right? So so see, let us consider there is a band, conduction band, and there is a valence band. So what happens? Most of the electron will reside in the valence band. Whenever you will put energy or give energy, and if this energy is greater than the energy gap, that is this gap, this gap is called 0.72 electron volt energy gap. What do you mean by this? In as per this, whenever you will apply a energy or you will give an energy greater than this, so what will happen, electron will gain some this energy, and it will jump into the conduction band. And as soon as it will jump into the conduction band, so what will happen, electron will start flowing under the action under the action of an electric field. The hole moves toward the negative potential giving a whole current, and the total current I is the sum of the electron current and the hole current. Now see, let us consider this is a semiconductor. In this what happen, this side this is positive terminal and this is a negative terminal. So what will happen, electron will move in this direction, so which will create a electron, so current is due to electron. At the same time positive charge will also appear to move in this direction from positive to negative, so it will also create a current, and so total current will be equal to current due to electron plus current due to hole. Okay, and same intrinsic semiconductor is a pure semiconductor and there is no external doping in this case. It may be noted that apart from this process of generation of the conduction in an electron in a hole, a stimulus process recombination occur in which the electron recombine with the hole at an equilibrium. The rate of generation is equal to the rate of recombination of the charge carriers. So the recombination occurs due to the electron colliding with the hole. Now let us suppose this is your conduction band and this is a valence band, right? Electron is there, this is a hole, so electron will move from this to this. So what will happen, electron will move from this to this positions, right? So it will create a negative charge, that is electron, but here it will create a vacancy, that is positive charge. At the same time, some type what happens, electron may come again and take place this positive charge, and this phenomena is called the equilibrium phenomena. Means as soon as electron will go from this position to this position, so empty is being created, but at the same time another electron may enter into this to fill up this gap. So this will happen, this process continues, right? Now next is our extrinsic semiconductor. A conductivity of an intrinsic semiconductor is very low at a room temperature, but it can be significantly increased if some pentavalent or trivalent impurities is mixed with it. Hence, those semiconductor in which some impurities of the atom is embedded are known as extensive or impurity semiconductor. So now let us suppose there is a silicon, there is a silicon, there is a silicon. So there is a silicon. Here is also silicon. There is also silicon atom. Everywhere there is a silicon atom, silicon atom, silicon atom. Earlier case, what happens? That definitely there will be a movement of the electrons, so it will create a current. So what will happen? What will happen? The current or the conductivity of this material is very low. But at the same time, all are connected with this each other. All are connected with each other, and all are connected like this. And it is called tetravalent bond or covalent bond. Covalent bond. All are connected with the covalent bond, right? Like this. Now this is your pure semiconductor. Now what will happen? I need to dupe it. So if you want to dupe it, so what you need to do? You need to remove this central or any of the silicon atom, and just if you want to dupe it with the pentavalent or trivalent. So let us consider trivalent. So let us consider this is an aluminum. So earlier what will happen? Earlier what happens? Electrons sharing were there, but as soon as aluminum comes, so sharing, it has only three electron, one electron, two electron, and three electrons. So it will create a sharing to this nearby, but there is no extra amount of electrons, so this sharing will not happen. It means that this hole is extra hole is created, and this hole will help to conduct electricity. So there are two type of dopants used in doping. First is trivalent valency 3, indium, boron, aluminum, and second is pentavalence valency 5, example arsenic, antimony, phosphorus. So we may dupe like this. So if you, let us consider, if you want to dupe it with the pentavalence, so what will happen? what will happen? Just you need to remove aluminum and you have to put it with the phosphorus. So phosphorus, since it is a pentavalent, so what will happen? Its electrons, how many electrons are there? 5 electrons are there. So all has been shared with the silicon semiconductor, but there is an extra amount of electron will happen, and this free electron will help in the conductivity. So this is pentavalent doping. So there are two type of doping, pentavalent and trivalent. So see, extrinsic semiconductor are basically how many types of semiconductors are there? Two types. One is N types and another is P types, right? Now N type this. So let us study one more details. N type. This type of semiconductor is obtained when pentavalent impurity is added. Why N times means what? Negative. N times means negative. Negative will happen when negative will happen. Let us consider again. Just make it. There is silicon Si, 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 Si. But I have duped it with the pentavalence like phosphorus. So what will happen? 5 electrons are there for phosphorus. So what will happen? Every electron gets shared with the silicon, but one extra electron will be there. So if extra electron are there, it means it is negative charge came out. So this type of N type, this is considered as N type semiconductor. N type extensive semiconductor conductor, right? And it is doped with the pentavalent, doped with pentavalent pentavalent element. So whenever there is a doping in which there is a pentavalent will happen, so you can consider it pentavalent. So hence these electrons are almost free to move, and the other words we can say that these electrons are donated by the impurities of the atom. So these are also called as donor atom. So since it donates the electron, so it is considered as a donor atom. Donor donor atom, because it is donating an extra amount of electron. And the conduction inside the semiconductor will take place with the help of this negatively charged electron, due to which the negative charge this semiconductor are known as n-type semiconductor, right? So since this is your negatively charged, so this will be considered as the n-type semiconductor, right? Now very important, this is n-type semiconductors. When the semiconductor are placed at a room temperature, the covalent bond breaks take place, so more free electrons are generated. As a result, number of generation take place, but as compared to the free electron, the number of are compared to the less due to the presence of donated electron. See, since donated electrons are extra, so from here we can say that the number of electrons will be more, right? Here number of electrons will be more. Therefore, the major conduction in n-type semiconductor is due to the electrons. So the electrons are known as the carrier, and the holes are known as the minority carriers, and electrons are known as major carriers. So finally, in n-types, electron are major carrier for electron, carrier for current, sorry, for current, right? Now we will discuss about the p type. So p type means it is your positive charge will be there. So again, just you need to draw it. So let us try to understand. Hmm. There is a silicon, there is another 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 silicon. Okay, what happens? This will create a bond, this will create a bond, this will again create a bond. So all are covalent bond, all are interconnected, right? Now I want to dupe it. So if you want to dupe it, so what will happen? Just you have to remove it. Since it is p type, so I will dupe it with the aluminum. So aluminum, so what will happen? It has how many electrons? 3 electrons are there. Outermost orbit has 3 electrons, so there it will get shared like this, it will get shared like this. But there is an electron, but there is a hole as well. As hole has been, extra hole has been created. Extra hole has been created. Is created in this topic. So in p type of doping, p type of doping, number of hole is much more greater than the number of electron. So we can say that the majority current carrier is due to hole, and this is considered as the pole, p type of semiconductor. Hole, since hole is positive, so that's why it is considered as a p type or positive type semiconductor. So I hope you have understood this. Okay, so hole and in an extra, right? So I hope you have understood this. So I will discuss more in the next session. Thank you. So you have understood p type and n type. Thank you.